prediction only task, we'll go with encoder only architecture. Okay, in other way around, I can easily differentiate like this. Whether you want to label the sequence or label each tokens in the sequence. What is the difference between these two? Can you able to comprehend these two statements? Label the sequence, label each token in the sequence. How do you look at these two terms?
Text classification and POS tagging.
Very good. Ajay works at Amazon Bangalore office. As you mentioned, POS tagging or named entity recognition, in that task, what I'm supposed to do is each and every token, I'm going to label it. Whether Ajay is the name of the person, works is a verb. We have in the English sentence, we have a preposition, conjunctions, adverbs, lot of things are there. But if my application is focused only on the named entity recognition, okay, one label, output label I reserved for the name, okay, name of the person. Another label I reserved for organization name. Another label I reserved for location. The fourth label I reserved for others. Others in the sense all the connection words. Okay, others. For simplicity, I have given 4 labels, but the commercial named entity recognition application, they uses more than 4 labels, because as I told you, when we talk about the byte pair encoding, your name will not be splitted into one full. It will break down into 2 or 3 pieces. Depend upon the context, it will recognize whether it's the name of the person. Okay. So similarly, sometimes your organization name is split into 1 or 2 pieces. Locations are split into 1 or 2 subwords. So the commercial model uses nearly 15 labels in the 15 nodes in the output. Similarly, parts of speech, I have to label a particular word. For example, works it's a verb, whether it is a subject, it is a noun, or it is a preposition, conjunctions, adverb, adjective. Likewise, commercial model uses 45 labels for POS tagging, 45 labels. So what this model is going to do, label each tokens in the sequence. During the training process, okay, this Ajay token should maximize this first node, probability of the first node. Remaining 3 nodes, it has to minimize this. Similarly, this token, works token, has to maximize the 4th node, because works, it is not part of these 3 classes, right? Others, it will come under the others. At also come under the others. Office also comes under others. Work, at, office, these 3 guys should maximize the other 4th node. Amazon is an organization name. I will be trained the model in such a way that maximize the 2nd node, which is the organization. Bangalore, I will be maximize the 3rd node probability. So thereby, my model will be learning from the given sentences. It will identify which is the name of the person, which is the organization name, which is the geographical location. It will learn during the training process. Of course, I will be teaching you in detail how the architecture or how the connections goes on, what is the logic and all those things. Whereas label the entire sequence means, okay, I'm not attaching each and every token will not be taken to the output layer. So whatever the connections I'm showing you was only the output layer. Please understand the decision-making layer. Before that, there's a lot of processes going on. Okay, transformer layers. That's what we are going to study in detail. What magic these guys are going to do. Okay. Whereas label the entire sequence, I don't connect each and every token to the output side. Okay, there will be only one connection is going to have with the output side. Okay, that connection you may think right. You just put it in your mind and you think over which token the connection will be take down from this. Okay, just you think about this point, right? When we talk about this in detail, that time you are able to, for the entire sentence, there is only one connection will go, and it is going to say whether this is a whole sentence for sentiment analysis or text classification and all. Hey, whether the whole piece of text belongs to what document, whether it is a scientific document or it is like some art document, or it is about some sports document or whatever it is. Classification according to the number of classes, you need to set the number of labels. If it is for sentiment analysis, if the two sentiments like a positive, negative sentiments, from this output representation, you'll be connecting to, okay, one token, you'll be taking the connection to the output side with the two nodes, positive and negative. So this is for encoder-only architecture. In encoder-only architecture, either you will be labeling the entire sequence, or each and every token in the sentence on the sequence, you are going to label it, whether it is a named entity recognition or like a parts of speech tagging. So these are all the four popular applications whenever we use the encoder-only architecture. What are all the four applications? Sentiment analysis. Okay, well, your very popular application, whether it is a two sentiment, mostly two sentiment, positive, negative, sometimes neutral also, but the neutral is very rarely people use it, otherwise positive, negative. Then text classification. Text classification can be multiple use case. In healthcare, you can categorize the document based on cardio, neuro, pediatric. Likewise, based on the content, you need to identify and classify, or legal documents. Whatever the domain you work with, it is good based on the content, it is going to categorize the document, or even the news articles, the sports news, political news, science news. Any text, if at all, if you wanted to classify, you can use it for the text classification. Any number of classes, there is no limitation. Text classifications or news article classifications. Number 3 is named entity recognition. Number 4, POS tagging. Out of these guys, okay, I just put these two in one bucket, these two in another bucket. What is the difference? Here, the whole sequence we are labeling. Here also, the whole input sequence we are labeling. But these two guys, token-wise, we are labeling. So this is the one important understanding whenever we design encoder-only architecture. There are 4 type of designs, 4 type of applications, popular applications. So those 4 applications broadly divided into 2 categories, the entire sequence label or token-wise label. So